Thanks for joining us today. My name is Jeff. This is a project with my collaborator, Rupak, who's at the Max Planck Institute. He's also on the call today. We're going to talk about Data Workspaces. It's a tool for doing reproducible data science. And it's an open source project written in Python. So this project started from a natural language processing machine learning project that we were doing together, and basically ran into all kinds of challenges that I'll talk about here. And I was pulling out my hair, and it was very frustrating. And so I felt like there was like better tools. We come from a software engineering background, and there were kind of software engineering tools we could help to build to solve some of these problems. So like the first kind of pain point that we saw is that when you're working on data science projects, the data isn't all in one place. So first of all, you have your code, which you might keep in a Git repository or somewhere else. You have various data sets and various versions of those data sets. And sometimes the data may be sensitive. For example, we were analyzing people's emails, so we couldn't just leave those laying around. Also, as soon as you copy things to your laptop or you copy it to a cluster, you have multiple copies laying around. So this can be a challenge, keeping track of it and knowing which data set and which version of the data set you used to run a particular experiment. And speaking of experiments, kind of the second problem is what I would call reproducibility and experimental control. So obviously, if you're doing something like climate science, you want to be able to prove how you got to your final result, because you may have people kind of questioning how you did that. But even kind of for more mundane experiments, when you're kind of trying out different things, so you're doing hyperparameter tuning, for example, you want to vary one parameter at a time and keep the state of everything else the same. And if you have a lot of different parameters and a lot of complex state and maybe a multi-stage pipeline, that gets to be hard. So this is a challenge. And kind of like another example of this is like one day when I was running my experiments, I ran an experiment I had done the previous day, and I get a result that's like 5% less accuracy than I had the day before. And so trying to figure out, is that just because the random sampling was different? Or is that because I didn't change a parameter that I thought I had changed, or the parameter state is different than I thought it was, or maybe I introduced some bug in my code. So kind of all those things, trying to figure that out, it can be very challenging. So we kind of want to kind of capture the state of everything so you don't have these kinds of problems. And then finally is collaboration. So there's a couple aspects to this. One is that when you start a new project, a new person starts your project, you want to be able to get the state of the project onto their machine or laptop or whatever, or you want to pull it out down onto a cluster. And if it has multiple moving pieces, that can be challenging. And then the other part of this is you want to share code and results as you're going along in the experiments. So these are kind of the pain points that we ran into. So our solution is called Data Workspaces. You can think of it as it's really a thin layer over Git, written in Python. And the idea is that we maintain some metadata about your project in Git, and basically it's tracking kind of the different kinds of data you have, which you can look at it being your kind of source data, intermediate data that's generated from different steps that you've run or different analyses you've done, your final results, which are maybe some data results. You might also have kind of various metrics you're capturing or graphs you're building, and of course your code that you use to generate all this. So we store this metadata in Git, but your project data can be stored in Git, or it can be stored in local files, or in an S3 bucket, or Google Drive, wherever you want. And so we provide kind of what we call a snapshot. You can think of it underneath the covers, it's doing a commit in Git, but it's basically capturing the state of all these different pieces of data that we're tracking. And so that that when you got to a final result, what was the state that got there? And then you can restore back to that workspace if you want to reproduce the experiment. Or you can restore part of your workspace back as well, independently of other parts. Finally, we have an API integration. So this will allow you, right now it's with TensorFlow and scikit-learn, and it allows you to automatically pretty much take the code you already have, and by doing a few extra imports, it will capture the state of your models and what their inputs were, and kind of what was the parameters that were passed in, and the metrics that are generated for you automatically. So you don't have to write extra code to do that. Okay, so now I'm going to show you a quick demo. And let's see here. Okay, so actually, let me start first with the command line. So Data Workspaces has a command, today it has a command line interface and a integration with Jupyter Notebooks. And so I'll show you the command line very briefly, and the integration with Jupyter Notebooks a little more. And kind of longer term, we want to also build a GUI for this. But the basic idea is on the command line is that there's a command DWS. It's kind of like Git, that has a number of subcommands. So these do various activities. And kind of we're going to go through what some of these mean more in a little bit. And you can also like to say help, and it gives you kind of all the kind of all the options you have and things. And we have full documentation on this. So there's a command line interface, and it's using Git under the covers for a lot of things, but it's trying to be higher level. So things like when you take a snapshot, it's going to do a git commit of your workspace and of any resources that you have, where a resource is basically one of these collections of data. And when it does that, it's going to add any files you need and kind of do some of the bookkeeping that you have to do manually if you're using Git directly. So one thing I'll show you, so we can do. So here I have a little project, and you just kind of report status command is showing you I have these 3 resources, and the resources can have basically a type. So one is an external Git repository, and these other 2 are subdirectories in my workspace. They also can have a role, which it kind of corresponds to those roles I was talking about in the slide. So this is the famous digits data set, handwritten digits. So we want to kind of recognize those digits. And that's source data that we're going to have, and it's coming from an external repository. We have our code, which is going to be a Jupyter Notebook. And we're going to have our final results, which will be capturing metrics and as well as the model. So, and I already created this workspace, but you can see here I have some directories. So the code, oops, if I spell correctly. The code directory there has my notebook. You can look in this digits data set is a separate Git repository. It has all the data and the results. Doesn't have much in there now except for this snapshots, which is a subdirectory. And the idea with this is that for some things like code, when you always typically want to keep like you would do in a source repository and keep the latest version. But for something like results, what happens is when we take a snapshot, we move everything to a separate subdirectory, because really you're not trying to overwrite your results. You want to kind of keep all your results you have. And so we'll see that in action in a second. So let me show you now. So this is a Jupyter Notebook that's in that workspace. So I'll walk you through this. So this first step is going to load some additional, this is called a IPython magic, but it's basically some additional commands that we're going to provide to Jupyter. And so this is just showing you what the new commands are. So I can run this info command, and it kind of gives me what I got on the command line. So it's showing you the different parts of my workspace. Now I'm going to import some files from some modules from scikit-learn, as well as these are some wrapper functions we're going to use from Data Workspaces. So the next step is I'm going to load a data set. So this is basically loading from the files on disk and storing the data in basically what's called a bunch, which is a fancy hash table in scikit-learn. So these are some hyperparameters I'm going to set, and for my particular experiment, and this is a support vector classifier, so it takes gamma. And I've tried different values in the past, as you can see, and now this is going to be the 4th run. So I'll just save those as variables. So here I'm going to instantiate, this is a support vector classifier with my gamma as a hyperparameter. And then I'm going to wrap it in this class from Data Workspaces called lineage predictor. And so for any kind of predictor class, it's going to add in scikit-learn, it will add lineage tracking to it. So what'll happen is when you run the training, it's going to capture what were the parameters you used for training and what was the input training data. Then when you run the scoring, it's going to capture the metrics that were the result of the scoring. And finally, I'm going to save the model that was trained into a file under results. Okay, so that's wrapping it. So the next step is just splitting the data as pretty standard scikit-learn. So now I'm going to basically fit the model and score it. And so this is obviously kind of unchanged scikit-learn code, but under the covers, it's going to be calling the Data Workspaces. So it ran it. You can see I got 88% accuracy, and it wrote this file results.json. So if we look back on the command line under results, you'll see this results.json file as well as the digits.joblib, which is the saved model. So this is a JSON file, and you can see it has all this information about the run, all the parameters of the model. And of course, gamma is the one we set explicitly, but all the others have defaults. And then finally, the metrics, so the accuracy, that 88%, and the accuracy for each of the different classes. So if we go back here, we can also see the same thing in the notebook. So if I run this command, it's going to print it for me. And so it's kind of easier way to view the same information. So now I want to take a snapshot. And so a snapshot is going to capture the state of the workspace. So I have this workspace, I have three resources. I have the source data, I have the notebook code, and I have my results. So it's going to capture these and associate those with the metrics and things that I've gathered. And I'm going to give it a message. So this is my message, and that gamma will be substituted with the gamma I use. And I'm going to give it a tag, which is run4. So it's going to run that, and it kind of behind the covers, it's actually saving the notebook. And it's, in addition to saving the notebook, then it's computing that, it's running the snapshot and computing the hash. So the hash is kind of like in Git. We have a hash though across the entire workspace, not just one repository. So I can, now that I have that snapshot, I can look at something. So this is showing you the lineage that was captured in table form, and it's kind of easier to see in graph form. The way you see is pretty simple in this case, right? I started with the source data. I ran this notebook, that's kind of the name on the edge, and I got this results. And these kind of numbers here, these hex numbers, are basically the hashes associated with that. And there's also a lot more information that's kind of stored in kind of our kind of little metadata database about kind of all the parameters passed into each step, as well as when they were run, how long they took, and that kind of thing. So one other thing we can do is look at the history of the snapshots we took. So I'm going to run this history command. And so you can see I've run 4 different experiments, and I've tried different values of gamma. And you can kind of, and you can see the metrics that were captured, and it's showing a heat map. So you can easily see that kind of the best result I got was 96 or almost 97%. The worst result was 10%. So obviously the kind of best gamma so far was this one. And so if I want to go back to that previous run and look at the results in more detail, I can do that for any previous run. So this is showing, you know, kind of all the detailed results for that best run I had. So that's kind of what the notebook looks like. And let me go back to the slides. So this is kind of a pictorial representation of the workspace. And again, you can see it has these 3 resources, which are just kind of a way of representing collections of files. And so we have one is an external Git repository, one is the code, and one is the results. And kind of when you run the scripts in this, basically what's happening is it's going to pull data from the source data. It's going to be operated on by the code and then written to the results. And that's what we saw in our lineage graph. So I wanted to show you kind of what a more complicated project might look like. So this is another project I'm working on where I want to analyze data from GitHub, and I actually have two workspaces for this. What you can see, so GitHub has an API, and unfortunately it's rate limited, so you can only pull down like, you can make like 5,000 requests an hour. And I want to pull down commit data, so if you have 1 million requests, it's going to take a few hours. You have to basically run 5,000 requests and sleep and that kind of thing. And you end up, and the way I'm storing it is not super efficient, but what I'm doing is every response I get, it's a JSON response. I just save it as a compressed JSON file. So in this workspace, which is focused on the downloading, I'm basically syncing up. I have a local copy that gets automatically synced up with S3, and it's basically got all the data that I've downloaded, and it's kind of an additive process. As as new things come in, I can add new files to this. And so there's this downloader.py and the code resource, which is doing that for me. And finally, there's a process.py, which will create an intermediate data resource. And in there, I have basically it's using Git LFS. And Git LFS is an extension to Git to handle large files. And I'm creating like a single large CSV file, compressed though at least, that has kind of the relevant data I need out of these 500,000 files. So basically, this thing does all the pre-processing. And when I want to work, so this other workspace is for kind of taking that particular file and doing analysis on it. And so I can export this resource from this workspace into another workspace, and the code can operate on it. And in this case, then I'm running a big Jupyter Notebook that's doing all kinds of analysis on it, and it's generating kind of various kinds of metrics and doing clustering and graphs and CSV files. So this is kind of the end-to-end thing. You can kind of see there's kind of two logical steps to this, but I can kind of keep these separate so that someone working in this workspace doesn't need to worry about all the original source data and how that got there. Plus, this data can be shared across multiple other workspaces. So not every project needs to be this complicated, but you can do different things like that. And I'll show you real quickly. So here's like for that project what the lineage looks like. It's still fairly simple, but you can see that this was the first step. So this was taking the giant 500,000 files and running the script commits to CSV, and that's producing this one CSV file. And then from there, in the other workspace, I'm taking that and running my analysis, and I have basically reports that are generated. And then so all the information, if I wanted to go back and understand those reports, and like in this case, the thing that's most interesting is what is the set of repositories that were captured, and what was the effective date of the report in terms of basically what was the cutoff of that. So that information is automatically kept for me, so that if I wanted to go back and look at this in the future and understand how I got there, I can do that. Okay. So let me talk a little bit about kind of the workflow with someone using this. So these blue boxes in this workflow are commands that we'd use from the command line. And like I said, most of these have analogies in the notebook as well. So in this case, if you're starting out a project, you would run init, which is kind of like git init. It basically sets up your metadata. And if you don't have a Git repository, it'll set that up for you. You can add resources. Then you run various experiments. And then you can review results. Then you can go back and forth as many times as you want. When you have something you find interesting, you take a snapshot, and then that's kind of kept for posterity. And you can also restore from a past snapshot as well. So this is kind of the workflow of one person. And then when you want to collaborate, what you do, so because the metadata is a Git repository, we can host that on any code hosting service like GitHub or GitLab. And so that could be either in your own environment or the public cloud. So there's a publish command which will push that up to the code hosting service. And from there, the workflow is similar to Git in that basically people can clone their workspace, run experiments, push up their changes, pull down things. And so it's very similar to Git, although we try to make it a little easier on you and do things so that you kind of avoid having, say, like merge conflicts and things like that. And so the idea is a data scientist doesn't need to know all the details of that good stuff happening under the covers and can still collaborate on experiments. So this, talk a little bit about some of the integrations we've built so far. So this idea of resource types, there's basically for talking to these different things, there's an extension API. And so we've implemented several, so you can store your data obviously on local files and NFS. We have, like I mentioned, there's an rclone utility which kind of integrates with many different data storage formats and services. So like S3, Dropbox, DigitalOcean, Google Drive. So there's many that it can sync with. Git itself can be used as a resource, either as a subdirectory or as a separate repository. And we integrate with two different kind of for extensions to Git, and these both Git LFS and Git FAT are for kind of storing large files, because one of the problems if you've ever done a data science project with Git is that it doesn't handle large files well. So these if you kind of turn on that feature, will you do that for you transparently? And like I said, so the workspace itself can be hosted in kind of any of these Git hosting services. And finally, at the API level, then we call these kits. And currently we have support for TensorFlow and scikit-learn and Jupyter. And we're working on some more now. So just to finish up, I'd like to say we have a number of resources that are available. So we have a website that we put together that has links to everything. So it's easy to remember, dataworkspaces.ai. And so if you go there, you can find there's tutorials. I have a few YouTube videos I've put together and everything. So there's lots of stuff there. It's a pip package in Python, so you can do pip install to get Data Workspaces. The source code is all on GitHub, and we have detailed documentation kind of with both tutorials and reference information. So, we'd like to thank you for taking the time to listen to this. And if you have any questions now, we're happy to answer. And if you have any questions later, you can contact us at info@dataworkspaces.ai or our direct emails, and we're happy to help you out and get started. So
thank you very much for the talk.
Sure.
If someone has any questions, you can unmute you or write them in the chat. Okay, someone is asking, what about virtual environments?
Good question. So what you can do, or right now it's mostly by convention, in the sense that basically I typically use the cond environments, but it's the same thing with virtual environments. It's basically you have the requirements.txt or environment.yaml file in your workspace, and then when you kind of pull it down, then you can just activate that environment. And we also have some support for creating a Docker container from that. So there's a command that will create a Docker container from your workspace if you want to do that. In the next release, what I'm hoping to build is that basically if you put a requirements.txt or YAML file, when you clone the workspace, it'll automatically set up that environment for you. So it shouldn't be too hard to implement, but that's kind of probably in my next release. And I'm going to try right now to share the slides. If this works. So I'm going to put them in the chat. I mean, I can also put them in the comments of the thing, but so I just shared that was the PDF of the slides.
Okay, so if you are okay with it, we can also link it on the meetup page.
Sure, that'd be great.
Okay, thank you. Okay, so if there are no more questions, I think we can finish the meetup. I thank again both the speakers. Very interesting talk today. And okay, so Good evening to everyone.
Thank you.
Thank you for having us.